Hello everybody on the Unreal Engine 4 and mobile tips and tricks talk. I'm really glad you're all here, especially after what happened this night. And I'm Damian, and I'm the senior programmer at Vivid Games, and I'm working on the engine and research and development department. And I was working on such titles as Real Boxing 2 and Mayhem Combat, which will come soon. And I'm also the blog writer, if you want to check. And what this talk be about? I just want to point some easy-to-miss Android settings, which are very important at the beginning of the game development in Unreal Engine 4. And I will also talk about the reducing the build size and some about the scaling, optimizing, and profiling your game on mobiles. So let's just start about the easy-to-miss Android settings. First of all, when you are starting your adventure with the Unreal Engine 4 and you want to make the game on mobile and especially for Android, is that you have to know that you must have the very specific versions of the Android SDK and NDK. And without these following versions, the engine will probably not work. And if you want to use the newest versions of the SDK, then you will have to dig around and modify your engine a little. The most important thing is that you should always use the SDK level 24. If you want to update this, you will have spent a little more time. And the settings that were shown on the previous slide are not the settings that are per project. These are the settings that are globally set for your building machine, and you can check these settings in this configuration file. But just remember, they are global for all projects on your computer. Luckily, in the newest version of the engine, you can override the SDK and the NDK version per each project, so it's a bit more convenient. After you have set the SDK and NDK properly, you also have to set up the minimum and the target SDK version to have the proper version in your Android manifest. One important thing is that because the Unreal Engine requires the specific version of the NDK, which requires the specific version of the SDK, if you will set the minimum SDK version at something less than 21, it will use 21. This is the minimum version that the Unreal Engine 4 supports. The another neat option that is very often missed by developers is to enabling the full screen immersive mode on the KitKat and above versions. It will just hide all of the system buttons if they are on the screen and not physical, and it will just boost the user experience a lot. Another easy to miss setting is to use the external files directory, and this I'm not sure why this is not enabled by default, but when you're starting the project, you should enable it by default by yourself. This is because if you will not set this, the Unreal Engine will store all of your game files inside of the external storage directory, which requires the extra permission. And when you start the game, you will just see the pop-up that the game wants to use your files. And it might confuse some players why. And just have in mind that it will work only when you build for the distribution builds. Unreal Engine must store files in the external storage directory in development builds for the debugging purposes. And also the orientation of the game. By default, the orientation is set into the landscape. But when it's set to the landscape, it will not rotate when you rotate the device. If you want to have rotate the game when you rotate the device, you have to set up to the sensor landscape. From the Unreal Engine 4.18, the Unreal Engine uses the Gradle build system at its default build system, not the end. And I really strongly recommend to use it because it just builds a lot faster than the end. The one trap is when you are using it, you have to accept the SDK license, and you must have installed the Android Studio. And if for some reasons you will accept the SDK license before you install the Android Studio, you might encounter a lot of really strange bugs when compiling. But fear not, if you just do something like that, you can clear up the SDK license by removing this file, and then you just install the Android Studio, accept the SDK license once again, and then everything should work like a charm. And there is one bonus tip. It's not in the settings, but you can enable it from blueprints or from C++. When you don't want your game to when you don't want your device to shut down when your game is working, just disable the screensaver. Just have in mind that when you leave the device with the game open, it will just drain your battery probably like crazy. But it's usually very useful for the QA when you are testing the stability for the long gaming sessions. And in fact, that were all of the easy-to-miss Android settings. When you set all of your project as you want, then you just want to build your game, and then you suddenly notice that, well, it's pretty big. The APK and the OBB file takes over 100 megabytes. On the third-person example, very simple map for the developer build. So when we saw this size, we were just curious, why is it so big? So we just go inside the OBB file and check what assets are cooked inside. And inside there is the PAK file, which is the Unreal Engine archive file that holds all of the assets used by the game. And if you want to check what's inside there, you can extract this file using the Unreal Pack application that it's inside the engine. Or you can just check the log files, and there will be the list of the all assets that has been packed inside of there. And when we extract this PAK file, we just see that there is a lot of unnecessary editor content, like editor materials, editor sounds, editor, etc. Luckily, there's the option for it inside the Unreal Engine settings. There's the exclude editor content when cooking. I'm not quite sure why we would like to have the editor content. Probably when you are building on desktop and you want to have some kind of visual debugging, you want to make you want to make the build with the editor content as well. And when you set it up, the OBB file will shrink immediately. Even with these settings enabled, we can see that not all of the unnecessary files has been removed. There are the sample maps and the tutorial assets, which are the tutorial for the editor, in fact, also included into the game. But when you put the pack blacklist file into the build directory of your project, you can explicitly remove all of these directories, which will also remove them from the game. And the last option to remove the OBB file and the content file is to enable the compression of the PAK file. It can increase the content loading time because it has to uncompress when loading, but for small mobile games, this time is unnoticeable. And it also doesn't impact on the quality of the content, so just check it and you have the small build. And always remember the obvious thing that the shipping version will be much smaller than the development version. And after the conclusion, we can see that we have about 58% of the reduction of the size on the Android build, and we can also apply all of these settings to the iOS version, and here we can get even the 69% of reduction. So at the beginning, even at the beginning of the project, when to set all of these settings, you will just start with the smaller size of the application. If you want to reduce the size even more, you can disable the specific elements and parts of the engine using the configuration file. You can disable the plugins that you are not using, or if you are not using the dynamic point lights in your game, just set up in settings to 0. So the engine will optimize the rendering pipeline and the shader programs, and all of the assets will also be much smaller. Just have in mind that enabling and disabling the parts of the engine will require you to rebuild the whole engine, so the source code will be required. And after that, when we reduce the size, we just have to take a little look at the profiles of the games. When we are talking about the profiles, we'll just check the two configuration files, which are the default device profiles and the default scalability file. And sorry. And all of them are holding all of the information you have to know. You can display them on the editor, but I usually prefer to just check the files themselves. And for example, in the defaults and in the scaling configuration file, you can check the settings that are set for specific versions of the mobile. For example, we can have the profile Android low, which sets the specific, like here, the shadow quality and the effects quality to low, so it can run much smoother. And also we have the quality groups, like here in scale profile, you can see the effects quality set to 0, and these settings will set all of the other settings that inside this quality group, effects quality at 0. And okay, we can set up all of these different settings for different platforms, but how the Unreal Engine knows which profile to use? For the iOS, it's pretty simple. We don't have much of the devices from Apple, so we just have each profile is for a different device. For iPad 4, iPad 2, iPhone 5, iPhone 5s. Every device has a separate profile. On the Android, the thing is pretty much complicated because we have tens of thousands of devices. And here we are using the Android Profile Selector plugin, which will just check the match profiles. And here we see the match profile that checks the source type of the GPU and compares it to that string. So if the GPU family matches this string, we just enable the profile of the Android Adreno 5. And we can compare and check the profiles based on the GPU family, the OpenGL version, the maker of the phone, the specific models of the phone, or even the Android version. Just have in mind that the profile selector will always select the first match that will match. So you have to take cautious when you are writing them. So if you have two match profiles that are very similar and they are matching both, it will take only this one, the first one. And when we already set the engine to select the proper profile, we have to have in mind how to scale the game inside of this profile. And as you could see inside the configuration file, there were a lot of different settings, and I just want to mention the most important ones. And I think one of the most important is the mobile content scale factor, which basically sets up the resolution of your game. And when you set it up to 0, it will always run on the native resolution. which on some of the Android devices might be the overkill, because we have the Android devices with the full HD or even higher resolutions on very small screens. And so if you set the mobile content scale factor on Android to 1, you will just launch with the 720p, and everything between them will scale the resolutions as follows. The another option is the material quality level. You are setting this parameter inside the configuration file, and then later you can use it inside the material editor. So you have the quality switch in the material editor, and you can create different materials for the high-end devices and the low-end devices. So this is also the pretty handful thing. And there is also the feature level. It is also the node inside the material editor, which will tell us if we are running on OpenGL ES2 or we are running on OpenGL ES3 or Metal on the DirectX. And the pretty good practice is to display some placeholder material on the DirectX version. So if someone will launch the editor on their PC or Mac, they will see these placeholders. And to see the game as the game looks on the mobile, you can set up the rendering, the preview of the rendering level inside of your editor to the Android preview, which will enable the OpenGL ES2 feature level. And about the other parameters, okay, the mobile content scale factor, we've been talking about this, the bloom, depth of field, light shaft, and refraction quality. Well, I think this is kind of self-explanatory, but if you are not using the bloom or if you are not losing light shafts, I recommend to set this option to 0, so the engine will optimize the rendering pipeline and remove all of the unnecessary render passes. There is the streaming MIP bias, which sets up the minimum level of the MIP map of the texture. For example, if you have the low-end device, then you can say this low-end device to display only textures on the higher, so in lower quality MIP maps. The same thing is about the skeletal mesh and particles. There is also the detail mode, which says which actors to render and which not, because every actor can have set the minimal detail mode to be rendered. There is, of course, the shadow quality, the material quality level, which we've been talking previously, and view distance scale, which will change the value of the max drawing distance. So if you have the open world mobile game, you can just remove the objects that are rendering far away on low-end devices. And if you are interested in all of these settings, you can check this page, and there is the list of all of these parameters with the description. But you can also create your own parameters, like in Realboxing we have this really, talking a lot parameter is low-end, with just specifying if this device is really not great. And for example, when we were launching on the lower devices, the Realboxing, all the crowd, we replaced the crowd from the all 3D models to just unlit billboards. It was looking pretty good, and even the low-end devices could handle this. And there's, of course, the UI, which is sometimes pain in the neck, but you have to really deal with it. The basic option to scale the UI in the Unreal Engine 4 is to set up the DPI scale, the DPI curve. It just takes the shortest edge of the device, which is on the x-axis, and then, for example, if we have the device with over 4K resolution, we are scaling the UI by 4, which is the value of the y-axis. But we kind of noticed that this solution is not working pretty well for us, so we're creating the custom scaling rule class. And when we create this custom scaling rule class, you can apply any changes on the default DPI curve. And here we just created another variable that we can profile, and we were just scaling the UI on each iOS device separately, so we could tweak the size of the UI as we wanted. And here are some examples. For the Android and for the iOS, we had 2 different strategies. For the iOS, we kind of took all of the devices available and we made the profile for each of these devices separately. But for Android, this is of course not possible because there are too many devices. So we just created 3 profiles, which is low, medium, and high. And based on our QA and tests and benchmarks, we just set the low, medium, or high profile for specific devices. And as you can see on this table, there are 2 values because each game we are working on might have a different profile values. And just like here, there's just some example of the parameters we used on the iPad mini 4, and they are the parameters that are already in engine, but there are also some of the parameters that we just created by ourselves. Okay, so we kind of do all the things we had to do. We reduced the size, set all of these Android settings. We created the profile so each device will work as supposed to work, but there might be still some problems with the performance and we just kind of don't know where. So it's time to optimize our game. When optimizing, the draw calls are your biggest enemy. The more draw calls, the game will work slower, and there is really painful to just reduce them. So the first thing, how to check them. You can run the stat scene rendering. On the PC, you just press the tilde, and on iOS and Android devices, you just tap with 4 fingers on your screen, and then you can type any command you want. And with the stat scene rendering, we can check the mesh draw calls. And if you are interested, how many draw calls the skeletal mesh are causing, you can also check the stat engine. And how many draw calls can we have? And based on our tests on the medium iOS device, we can have the maximum of the 70 draw calls, and it's kind of low. But well, the higher versions were causing the extreme big frame per second drops. So okay, so the question is how to reduce them. Well, you have the many draw calls and you have many objects that are drawn. And this is logical. But so the first thing you can do is to favor the big objects over the many small ones. And Unreal Engine has pretty nifty tools for doing this. For example, there is the Merge Actors tool, and there's the hierarchical instanced static mesh component, which can allow you to draw many of the meshes in the game by using single draw call. And in fact, I think I will just show you how this can work. So when we play the game, and here we can just type stat scene rendering, and currently we have about, this is the second from the bottom, mesh draw calls. We have 4 mesh draw calls. There's the plane, there's the sky sphere, and there's this guy which causes the true draw calls. And okay, so first of all, we can just put some cubes here, for example, 1, 2, 3. and hit play, please. And okay, we have 7 draw calls. When we don't look at them for 7, everything is logical. We have 3 more objects, but we can select all of them. And here we have the merge actors tool. When we just replace the source actors here and we merge the tool, we save them. Everything is fine. And right now we have only 5 draw calls. When we don't look at them, there's only 4. So the thing we did, we just merge all of them, but one of the main issue of the solution is that you just have the another extra static mesh. So you kind of cannot do anything with this. That's why there is the another solution to use the static the hierarchical instanced meshes. This is the actor component where you are setting the static mesh here, and here you are setting the instances. And when we put this on the scene, you can kind of see that okay, there's much more of them than I previously showed, and this is because I wrote the blueprint action to duplicate them. And thanks to that, you can see that you can easily modify and add and remove these instant meshes into your game in the runtime. And also each of this static mesh is moving separately, so you can update them also separately. And the best thing is that when you just look at the mesh draw calls, this whole structure is only one draw call. So you can pretty easy by using this solution create even thousands of the objects, and it still will be running smoothly on the mobile device. So,
can you do it on the fly? When you are creating objects during the game, can you do it?
I'm not sure if I understand correctly by the fly.
In the game, because I have a game where I create.
I think that the questions will be added. So you will be the first, okay? Okay, just remember. So the next step when you are trying to reduce the call calls is to set up your culling properly. The Unreal Engine has the 4 steps of the culling. The first is the distance draw culling. So the objects that are far away are removed from the rendering pipeline. Then we have the frustum culling, so everything that is not inside the camera frustum, it will be removed. Then there is the pre-computed visibility volumes, which is a volume that just pre-computes which of the object is visible and which not, for example, which is behind another object, and then apply it. And the 4th step is the hardware occlusion culling, which, as far as I know, it's not available on mobile because it's too expensive. So the frustum culling is kind of free, you always have it, but if you want to have the cool distance, if you want to have the distance culling and the pre-computed visibility volumes, you have to set up your volumes properly. Use only one material per mesh. It might be very difficult for the artists to combine all of the goodness to only one material, but every material on your mesh will generate another draw call. So if you have the static mesh with 4 materials, the static mesh will cause the 4 draw calls. And if you are using the UMG, which is the HUD system for the Unreal Engine, and if you are using the scrollies or the widget switcher, have in mind that even if the child inside the scrollies is not visible, the Unreal Engine will still trying to draw it. So you just have to handle manually which of these childs inside the scrollies is visible and which is not. And the another options when you are optimizing is the using of the invalidation box, which will cache all of these widgets inside the UMG and prevent from extra drawing and updating. Use as few main materials as possible and use the material instances. For example, in our new game, the Combat Mayhem, we have only one core material for each of the different characters. So you can have on the scene about 6 different characters, and all of them are using the one common core material. Try to avoid the transparent and max materials because they are very heavy. You can, if you are not using the roughness in your material, you can force the fully rough on the materials, and there's also other options like forcing the, removing the metallic parameter from your material, and it will reduce the whole render call in the rendering pipeline. Use only the default and normal texture compression settings on mobiles. If you will use the another one, like for example the displacement map texture compression, you might encounter a very strange bugs in the rendering. Of course, use the square textures with dimensions of power of 2. Try to avoid post processes which are extremely heavy on mobiles. Try to avoid dynamic light sources, which are also very heavy on the mobiles, and set yourself the limits for maximum number of bones per skinned mesh and the maximum number of triangles per mesh. And in fact, when you enter the editor content browser, you can use the expressions to check if, for example, you don't have any objects that, for example, has more than 75 bones. The number of 75 bones is the hardware limitation for the OpenGL ES2. As far as I know, the OpenGL 3 and Metal doesn't have this limit, but still it is the good idea to make some, by yourself, some limits just to not kill the device with too many updates. Use cascaded module shadows or not shadows at all, because the cascaded module shadows are the special type of shadows specially designed for mobiles, which are very light, but they generate extra draw call for each mesh. So in Combat Mayhem, we are not using shadows, and the game still looks pretty good. So you just have to decide if you really want to have shadows in your game or not. And also implement touch input, animation instance, and actor ticks in C++. Never use ticks inside blueprints, because this is just a performance kill. And when we when we optimize the game, we think everything should work, but still there might be a little problems. Very difficult to find, and there the profiling comes to our help. The first thing we are checking when we are profiling our game is to check the basic stat commands like stat FPS and stat unit. We just check displays the main 3 timers. The stat sound cues is pretty nifty because it shows the number of the active sounds that are playing. And there are also the limitations. For iOS, there are 16 sounds, and for Android, there are 12 sounds that can play at the same time, from what I know. And there's also the stat engine, with which about we've been talking before, and except the number of the skeletal mesh draw calls, it can also display the number of triangles on the scene. Now, when you are profiling, one of the nice options is the show command. We just toggle the elements. I will just hide this, and I can, for example, I can hide all of the static meshes and see if I hide all of the static meshes, if the performance show is greater or lower. I can, of course, toggle it and I can also show or hide the skeletal meshes. So when there is also the post processes, the particles. When you, for example, disable the post processes and suddenly the frame per second just jump up, then you might know that, okay, there is a problem with the post processes and I think I have to optimize them later. So there you can just check all of these commands. The another useful thing is to read the stat file. The stat file is the file that combines all of the timers that the engine uses. You can just type the stat start file and stat stop file. It will generate the stat file which on Android is placed inside of inside on this path, and then you can open the Android session front-end profiler and then check how much time each of the objects inside of the game take time. And for example, we had a situation here when for some reasons some developer were loading their file from the disk inside our HUD, and this file was also compressed, so in each frame it was loading this file from disk and uncompressing it by using the zlib, and it was just using about 1.5 milliseconds each frame. And well, we thanks to this tool we could detect this problem, and really easy to fix this. You can also debug the memory by using the memreport command, which will also generate the file which is inside the device. And then when you download this, you can just open this inside the text editor. And inside the text editor, the most interesting thing you can see is how many the current memory, which shows how much memory the engine uses, and the process physical memory, how much the game actually uses the memory. So this is the engine and SDKs and native codes all combined. After in the memory stats, you can check all of the memory stats and see how much memory all of these elements are using. For example, we saw that the texture memory used inside our game is pretty huge here, and almost all of this memory is used by this UI. Then there's the object section, which just displays all of the elements that are currently on scene. And you can see how many particle emitters or actors are on scene, and check if there are no any leaks, if all of the actors are properly destroyed or not. And lastly, there is the levels sections, which shows which of the sublevels are displayed on the game. For example, we had some developer that was doing some test stuffs on the debug sublevel, and then he forgot to disable it. So we had another extra sublevel that was working in the background, and we didn't notice until we ran this tool. And there is the last command, the list textures, which just shows the it lists the textures that are currently loaded into memory. So as we could see, the UI was using the most of our memory, and when we just launched the list textures, we noticed that the LS background 1 and LS background 2 textures are loaded into the memory during the game, while these textures should be loaded only during the loading screen. And during our tests, we discovered that if you don't want to have any issues with the memory, you should also have in mind to use only 50% of memory on the iOS and only 35% of the native memory on the Android. When you are crossing this line, you will probably have the memory warnings and much problems after that. So summarizing everything, try to remove everything unnecessary content at the beginning. Profile your game when on the low-end or high-end devices, so everything will work properly on every device. Watch out for draw calls. Use all mobile optimizations like cascaded model shadows that the Unreal Engine has to offer. Don't be afraid to use any profiling tools like all of these command stats I show, and watch out for draw calls. Notice I said watch out for draw calls twice. And I think that was all. Do I have a 1 minute or probably not?
Sure, you can have 1 minute.
Okay,
and after
I have the 1 minute because after everything, okay, I'm talking about doing the mobile game for the Unreal Engine 4, but okay, what did we do? And we kind of have a trailer for our the newest game that will come very soon. So. So that was it. Thank you very much.
We encourage you to come here and ask questions. We are recording them, so please come here and ask.
Hello, thanks for your talk. That was really, really great. My question was about those meshes that you put in one blueprint, and you can like make instance of them, right? Mm-hmm. And my question was, because you do it before in construction script, right?
In construction, when I was trying to do this in construction script, I had crashes, so I just do it in begin play.
Begin play, but yes. before playing the game itself.
Yes.
And I was wondering, because I am creating meshes and actors during the gameplay, and I was wondering if I can use this technique. If I have many meshes, I can put it in one blueprint, but during the gameplay, during the game itself.
I've never tried this, but I'm afraid not, because when you are using the hierarchical instance meshed component, you have specifically set which static mesh it wants to use. So, but I don't know how you are generating them, but maybe you can set up the placeholder static mesh and then modify the static mesh somehow, and then it should work.
Okay, I will try. Thanks.
I'm not sure if I answer it to your question, but.
Thank you.
Any other questions? The last chance.
There is a post-process effect Bloom.
Yes.
And you said it is very expensive, but I was using it, and unfortunately, most of the settings works on PC, but they don't work on mobile. And if you do, you know, is there any way to maybe new upgrade of the engine, or is there a way to make it work on mobile? Or is it hardcore programming stuff to just write a shader?
No, actually you can write shaders in the Unreal Engine.
I can't, but maybe you can.
But the shader programmer can. Okay, once again, the question was if the Bloom. No, actually, no. This is the limitation of the mobile GPUs, and sometimes something. I was talking about the rendering levels, the feature level. There is the feature level for the shader model 5, which is the equivalent of the DirectX 11. And there's the feature level ES2, which is the equivalent of the OpenGL ES2. And the OpenGL ES2, well, it doesn't have many, it doesn't have much power when using such effects as Bloom. Maybe on Vulkan it would be available. But I'm afraid it's not possible to use all of the features that are available on PC to use them on mobiles.
Okay, great. Thank you.
Anyone? All right. Thank you.